Now we're going to get into the meat of everything. The meat of the parsing and manipulating files and input of any kind. This is really where the rubber meets the road. This is where you're going to learn a lot of stuff. So we're again in the writers directory, and I'm going to go down into texts. In this directory, we've already seen the README. We know what the README looks like. All right, here's the README, here's the top of it, here's the bottom of it. All right. So what if I don't want to use less? What if I just want to see the first 10 lines of README? I can use head and just type out head. And head writes out the first 10 lines. If I want to write out fewer lines, I can do head-n5. There's the first, here's the first 5 lines of the README. I can do 50. Here's the first 50 lines of the README. I can also do the same thing with tail. So tail gives me the last 10 lines. And if I want the last 30 lines, I do tail-30, and there's the last 30 lines. And what if I want to see the first 10 lines of the last 30? There. Right there. So I can use head and tail to pull out specific parts of files. So for instance, you see this Feldman blah 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 CIA. There's this giant file in here. It's huge. Okay, I'm gonna skip ahead. I'm gonna teach you word count to start out with. There's a command called word count, WC-L Feldman. And I can see that Feldman has 5199 lines in it. If you use word count without the -L, you can see how many words and characters there are in the file, but I never use that. I only use it for lines. You can see that there's almost 5,200 lines in it. What if I want lines 4,000 through 4,010 of this file? Well, I can do the following. I can go head-4000, or actually 4010 of Feldman, piped into tail-10. And there it is. Right there, those are the 4,000. So you can immediately use head and tail to parse out, to cut and snip out parts of your file. Now, these are super, super useful. There's another command, which of course I didn't include on the sheet because I'm a moron, called split. Split for the machine learning people is a godsend. I'm going to do something right now. I'm going to remove names with something, remove those things, and I'm going to remove some tile. And I'm going to make a new directory called TTT. Okay, good. And I'm going to copy the Feldman into TTT and cd-ttt. Okay, good. What if I'm using this file in some machine learning algorithm and I want to split it, and I would like to split it into lengths of, say, 1,000. I can do split dash, I can't remember if it's I or L, 1000, it's L. Split dash L 1000 Feldman. What just happened? Well, you've got these weird things. So if I do word count dash L on everything here, you can see that all of these files, XAA, XAB, XAC, contain 1,000 lines, except for the last one that only contains 199. But all 6 of these files together contain 5199 lines because they have split Feldman into files that have 1,000 lines in them. If you would like to split your files up, this is a great way of doing it. There's another command, which I also didn't put on this sheet, which I should have put on this sheet, called shuffle. So what if I want to randomize this file and then split it? So on Mac, unfortunately, shuffle doesn't exist. The command is just shuff. On Mac, that command doesn't exist. You have to use something like Homebrew or Mac ports. Use Homebrew. Just use Homebrew, and then I think it's a brew install core utils, and that'll give you all of the basic core Linux utilities that you might be missing on your Mac. That's a huge thing. You should always do that. And that will give you shuff. And I'm pretty sure I've done that on this Mac. So let's check. So the easy way to check is simple. I'm going to remove XA. By the way, the reason the files are prefixed with XA is because split does that unless you ask it to do otherwise. I don't remember what... Here, I'm going to lie in... Okay, so Yeah, man pages are help pages on Unix, and sometimes they're great and sometimes they're not. So -p pattern is the thing that you can use to have it output to a specific different name. And so like if you have it do, so it will, oh no, that's not it. I'm sorry, that's not it. I can't remember. Honestly, I should just Google it, but I'm not going to do that right now. So I'm going to remove the X files right now. Okay, so, and now what do I have left? I have Feldman. Okay, if I shuff, and in fact, I think I have to G-shuff. By the way, tab completion doesn't just work on files, it works on your commands as well. So, like, if I'm trying to shuffle, here's all the commands I have, and I have a shuff command. Great, okay, so I'm going to shuff Feldman, pipe it into split-L1000, and now I have 6 files, of which 5 are length 1000, which consist of random lines from Feldman. So if I less XAA, you can see that I have this line BG Fact Lebanon Industries Banking Food. That line is somewhere in Feldman. And in fact, if I search on, I'm going to search on Lebanon in a less. Let's see if I can do that. Let's less Feldman and see Lebanon. Oh, yeah, so it's in here somewhere. There we go, right there. Boom, there's that line. Wham, right there at the top of the page. So that line randomly was placed first, and then when the split happened, it was placed into that thing. So now you can figure out how to do train test validation splits or cross-validation splits if you want to by splitting your files up. Really useful, obviously, and a great thing, and I should put these things on the sheet. They don't fit on the sheet, but I will figure out where to put them on the sheet. In any case, so those are split and shuffle, which are great. Now, let's go back a step. I don't think I need anything else in this directory. Actually, I'm just going to keep using this. Let's remove all the stuff. Let's go up one directory for a second. The README. What if I just want to write the whole README to the command line for some reason? I just want to literally... Actually, I'm not going to do it with README. I'm going to do it with this file because it's small. So what if I want to... So if I less that file, it's just this stuff. Okay? What if I just want to write that file out to the command line? Not like head, I could head that file and get the first 10 lines, but if I want all the lines in that file, it's simple. I use cat. Cat writes the entire file to your command line. Why would you ever do that? Well, because you can cat and then you can pipe it into other commands. So instead of doing like grep some things the file or whatever, some things the file, you can always do cat the file piped into grep some things. Why would I do that? Well, because when you're chaining commands together, sometimes it's nice for everything to be absolutely neat this way, and that way you have written the whole file out to start out with. So cat writes the whole file. What if I want to write the file backwards? That's something not a lot of people know how to do. Tack the file. Oh, I'm sorry. I used head on that. I can use tack on that. Yeah, there we go. There's the whole file backwards. There's the first line, the second line, the third line. Great. So if I want to reverse the file, I can just go that into reverse. And I can literally just copy paste this whole thing. There, I reversed it. All right, good. Except that I don't want to do that right now because I want to show you. What if I want to, so I'm going to cat that file again. What if I want to write every line but swap the order of the characters in the line? I can use rev to swap the order of the characters in each line. So the file, notice that the last thing is ZSE, then WCE. ZSE, WCE, TSE. I literally just did a right-left swap of the file. Why would you ever do this? You're going to learn real soon why you do this. Rev is incredibly useful when you're doing parsing of columns out of files, because sometimes it's a lot easier. If you are a wizard at regular expressions, and you'll learn what those are, if you're a wizard at those things, reverse is not necessarily like the best thing, but if you're not a wizard, reverse can be a lifesaver. So reverse is great. What if I want to reverse this file, and then I want to put everything in order? I really just want to sort this stuff. Well, that's fine. I just pipe it into sort. There's a command called sort, and there. Now they're all sorted. So there. So and I pipe it into rev again. Boom. Here are all of the. Here's that file. This file where all of the things are sorted according to their last letter rather than their first letter. Why would you ever do that? Because sometimes the things in column 6 are single letters or important and you want to sort things like that. It can happen. There's all sorts of reasons this can happen. If I want to numerically sort, unfortunately, none of these have numbers. So I'm going to look at, actually, I'm going to do something. I'm going to sort Feldman piped into less. So I'm just sorting this whole Feldman file. Boom. You may say, why is there all this blank space? Because the Feldman file contains blank space, and sort puts blanks ahead of anything. So these blank lines come first, followed by this. Oh, whoops, that was a mistake. Followed by this Sahara, followed by Beats, followed by Arabia. So it's sorting things, and notice that it's sorting capital letters before lowercase letters, and blanks before that. And notice that then it's sorting after blanks, it's sorting symbols. Okay, and then after symbols, it's going to start sorting when I get through the symbols. And it's got some alphabetical order on certain symbols, who knows. Then it starts sorting the letters, okay? And here's all the letters. And if I go down to the bottom of the file, XYZ right there. Cool. Now, weirdly, this file does not seem to have any numbers in it, which is really strange. I'm going to look for a file with numbers. Let's look for that. Let's go into SGMs, and let's less one of these files. I don't care which one it is. Oh, this file has a lot of garbage in it. Good. Here's a big file with a whole bunch of garbage. So if I sort that piped into less, well, there's nothing. Why is this file has a lot more blanks in it. So I'm just going to page down, page down, page down, page down, 5. There we go. That was 5 page downs. And we get to this. And notice you're going to start noticing at some point we're going to start hitting numbers. So, oh, there we go. We hit some numbers. Bang. Here's all the numbers. Awesome. Good. We hit our numbers and then other symbols as well. So sort does that. If I sort -n that file, I can't do this because less is the last thing in the last line. So I do that for the file piped into less. Now I'm doing a numerical sort on that file. 2, 3, 4, 5. And the whole point of doing the numerical sort is that you notice that symbols now come first, and when I finally get to the and then letters, and then numbers are going to be at the end. And notice that all the numbers are in order here, 2684, and it actually understands things like commas. So notice how all the numbers are in order all the way on up. It understands numbers, which is great. So it actually does numbers appropriately. And notice that it doesn't even care about blanks in front of numbers. It's sorting all the things by numbers. Sort-n is really nice, and yes, you can do this in Python, but if you can do it at a command line, why not? Like, if you can string these things together and it's a one-off, do it. If you're writing production code, do not do this. If you're writing production code, then you have to, I said don't do it. You have to think about whether or not, there's a trade-off. If you're writing production code, it should be code that everyone can read that's very legible. Bash scripting is sometimes not very legible. It's sort of like there's another language called Perl, which you may or may not know, and Perl scripts are notorious for being... Perl's incredibly powerful. It's a super powerful language, but oh man, is Perl impossible to read. It is so difficult to read. Perl is awful to read. And so Bash is not as awful to read as Perl, but it's pretty awful to read. It's not great. So if you're writing production code, you should probably avoid the bash statements unless you want performance. grep is so fast. And there's other things actually. I think there's a faster grep. I can't remember. It's called zgrep or something. I can't remember what it's called. But there are grep was the gold standard for a long time, and now there's one thing that's faster. But there are all these commands were made decades ago by people who had, like, when Unix was built. You know, this is 60s, I think. I don't know. And all these commands were built, and they had numerical recipes, so they knew how to make all these commands incredibly fast. So these commands are all super, super fast. They're really, really lightning speed. If you want to make production code and you need fast commands, you should probably compare these against what you're doing in Python to see whether or not there's a appreciable speed difference and whether you care about it. Because if you don't care about it, then maybe make your code maintainable and put it all in Python. But if you're just doing a one-off for yourself and you're just parsing through, you're just an analyst and you're tearing through files and every day is a different ad hoc experience, then all of these Linux commands are super useful. So if I just sort the Reuters file without the -n, you can see that at the bottom I get the letters instead, because sort and sort-n, is just put things in different orders. And you notice how it's not that sort cares about the blank space before anything. So I'm just literally page downing as fast as possible, and it cares about the blank space once I get through all this garbage. In any case, just trust me, it cares about the blank space. I'm going to go to unique now. Unique is fun. How am I going to do unique? Let's go into texts. And let's less the Feldman, maybe? I don't think this is going to be anything. Let's go back into that directory, and the file that I was working with was this one. Here's the sort this piped into less. So this is going to be a little wonky, but too bad. What if I want to only write out the lines that were unique in this file? So I'm going to sort this file and then pipe it into a command called unique, piped into less. And you may say, well, wait, what? These lines aren't unique. They are. These lines all consist of different amounts of white space, which is stupid, but it's very true. These are all the unique lines in this file. These are all the unique lines. Like, literally, it sorted everything, and it came up with all these unique lines. Okay, cool. Well, why do I care about that? Well, the fun thing is, let's pretend I want to figure out all the lines in the file. I want all the unique lines, but I want a count of all the unique lines. This line with whatever white space is in it appears 84 times in this file. This line with whatever other white space appears 36 times. These other lines, this line appears twice. Let's find one that has a 2 on it somewhere. Or better, let's actually just pipe that into sort-n. Boom. And go to the bottom of the file. Okay. The line that has unknown in it appears 1,000 times in this file. The line that has companies appears 1,000 times in this file. The line that has exchanges appears 982 times in this file. So that's really cool. And actually, what I'm going to do is, I hate looking at things in that order. So I'm going to pipe into TAC. There, I've reversed the order. Boom, right there. So you can now see, I have literally just strung together a sort followed by unique, followed by sort, followed by up, down, reverse. And you can see exactly what you can do with Unix commands. You can really quickly, I just figured out in like less than a minute which lines in this file are non-unique and how frequently they appear in this file, which is really cool, obviously. So now I can just see which lines, like, oh, Reuter, for some reason, appears 144 times, which is pretty gross. Text &#2, semicolon, appears 930 times. Great. Here's all the lines that appear. Company said appears 5 times. So here's a fun thing. I'm gonna grep this. I'm literally gonna grep this thing. Let me grep company said in that file, piped into less. Okay, cool. But I'm going to do something I actually haven't taught you. Remember when I said like the $ meant end of line? The caret means beginning of line. Boom, there it is. There are the lines in this file that begin with company said, and notice that the period is being taken as non-unique. I'm gonna make the period. I'm gonna use a backslash to make the period. It unfortunately grep is using sort of like a shortcut where period doesn't stand for period. It actually stands for wildcard for any character. If you put a backslash in front of it, then it stands for period. So I'm gonna do that. And there. Here's all the lines with company said, and you can see that 5 of them are just company said, 2 of them are this thing, and 1 of them is this thing. Cool. So if I look through the unique for these lines, I'll find them. And they'll have a 2 in front of them. So, like if I search for immediately disclose, here, immediately disclose, Boom, right there. So there you go, right there. It doesn't exist anywhere else. That's funny. So there we go. You see that the unique is producing what you want it to be producing, and there's the unique lines in the file. So unique does not unique needs the file to be sorted. Unique will not, like, unique isn't using an internal hash to like store things and then compare them against other things. Maybe you can do that, but I never do that. I usually just sort the thing and pipe it into unique. I've already looked at word count -l. So here's the thing. Here's a simple thing. If I sort the file and piped it into unique, how many unique lines are in it? I'm going to just pipe that into word count -l. Boom. There are 18,660. Oh, yeah, 666. Nice job. Lines in that file. How many lines are in that file normally? 31,436. So there you go, right there. So there's what unique does. It gives you all the uniqueness in the line, and I just use word count to tell you how many words are now in the file. So you can now take a file, find all instances in that file, all lines in that file that contain a particular thing, strip out all the non-unique instances of those things, and deliver the last 10. Or count them with word count. You can do all of those things with these commands. This is obviously super useful if you're an analyst and you're going through files just trying to find stuff. As a data scientist, it is invaluable because you're often functioning as an analyst doing this stuff. So this is great. Now I'm going to teach you echo. Yeah, that's echo. Echo just echoes back what you say. Echo, hi, how are you? Echo, I'm fine. This isn't going to work. Why isn't it going to work? Because that apostrophe, Linux takes that apostrophe to be, you haven't finished the line yet. So I'm going to use another apostrophe in there. I'm fine. Echo, I'm going to get rid of that. I'm fine, where I delimit that. There, I'm fine. Cool. That's echo. Why would you ever use echo? That's stupid. Well, echo seems stupid, but echo can be really useful for debugging and for variables. When I get into variables later on, you'll see exactly why echo is really useful. I'm going to teach you one more thing in this lesson, then we'll go on to the next one. The one thing, which is the really important thing, is cut. Cut starts to get at the heart of what everyone does when they're processing through columns or files with a delimiter in them. So I'm going to do the following. I'm going to go back up into the texts file in directory, and I'm going to by the way, my LL, this is real fast, alias LL. I have typed this command, and I've put it in my bash profile, so that every time I type LL, it types ls-laatr. And you can see, so I always use, so alias is something, I didn't include it in this because you don't really need it, but if you want to, you put that in your bash profile, and then it's great because then you don't have to worry about things because it's sitting in your bash profile. So I think so I look in, by the way, tilde stands for home directory, bash profile, and there's my alias right there. So that's my tilde bash profile. So now I have an alias. So I can do like alias hi equals echo, you are a moon unit. Oh, that doesn't work. Sorry, because I need, I'm stupid. I'm a total moron here. I need to put that in single quotes. Hi. There we go. Cool. See, that seems dumb, but it will save you a bunch of time. Unalias hi, because I don't want to do that, because there we go. Now hi does not stand for anything. Oh yeah, there's a file in this directory called, there's a file in my main directory called hi. Ignore that. I'm going to go into the text directory, and I'm going to go into, I'm going to less the Feldman thing. Yes, okay, the Feldman thing this works really well. So what if I, this is going to be annoying as anything, because this is going to have, no, it's got commas in it. Commas are fine. I can use commas. Okay, so what if I grep comma in Feldman into comma file? My last comma file. So there's all the things that have commas in them. Cool. Now, what if I want to see, and actually that's kind of dumb. I don't want that. Let me arm comma file. Let me go into the, I'm sorry, I know this is wasting everyone's time, but let's go into less SGMs, oh no, sorry, SGMs, 01, yeah, there we go. And I really want something in this directory that is split, equal sign. Let's go into SGMs, grep equals, and Reuters 01.sgm piped into less. Look at that. Oh, that's gorgeous. There, we can do all of our splitting based on that. That's fantastic. Unfortunately, wraps through the window, but who cares? Okay, so you see that these things, you see that this is a file basically now with a lot of columns in it, right? Because this is Reuters, topics equals yes, Lewis split equals train, CAGI split equals training set, old ID equals some unique ID, new ID equals this. Cool. So what does cut do? So I'm going to take that. I'm actually going to write that into a new file. Equal file. Okay. Cut dash D for delimiter equals dash F2 for equal file. Piped into less. Boom. These are the second fields of that file delimited on the equal sign. So notice that I'm going to less the equal file. And notice that the first equal sign is here, and the second equal sign is here. Oh, sorry, is here. So this phrase between the equal signs is the second column if you were splitting on equal signs. And that's what it wrote out. If I wanted to split on space instead, I could just do space you have to put between quotes. There, topics no and yes. Right there. And you're like, what is this type equals brief, whatever? Well, remember that some of these lines are not particularly good. Some of these lines have like text type, whatever. So if I grep for Reuters in this file, and I piped it into cut dash D dash F2, and I piped that into less, boom, here's your clean file. You just literally parsed out an entire column of that. And you can do dash F 4, 5. Let's pretend we go off the edge of the map. Dash F 8. I know there's not 8. It'll give you things, but there's no 8th column, so it'll just give you blank. It'll deliver blank lines to you. So what if I want the second and third ones? Yep, right there. What if I want the second and fourth ones? Right there. Cool. What if I want the second, third... What if I want the first, second, third, and fifth? 1, 2, 3, 5. There we go. That's the first, second, third, and fifth. So we just literally omitted the fourth column. Cut is fantastic at just parsing through any file that's delimited by a single character. It is so useful at delimiting through these things. By the way, I want to teach you guys something right now, and I don't have a file that's delimited with this, but I want to teach this to you because it's so useful. If you have a tab delimited file, and you do this, it's not going to... For tab delimiters, you have to do that, basically. It's annoying for some... It's just, you have to do that. If I do that with this file, notice that there's no tabs in this file. So what's it going to do? Well, since there's no tabs, and I'm asking it for the first field, it'll just deliver me everything. So there's everything. So it's easy. That's the whole, like, there's no tab in this file. So it's pretending, so since there's no delimiter, it just delivers the whole line. If I had asked it for 2 through 3, 5, this is all going to be blank lines. Oh no, it's not blank. Oh no, does it just deliver everything? Oh, it's just delivering, it just delivers everything because there's no tab delimiter. Okay, I'm stupid. So there we go. Here's the 5th column right there. Notice that they're all sorted. That's great. So yeah, oh, maybe they're not sorted. There's, look at that, they're not sorted. So I could pipe that into sort. Dash N, pipe into less. There we go. C-sex, don't know what that is. Yeah, but you can see right here, here's all the lines. It's all nicely delimited. So, yeah. So that's what cut does. Cut is fantastic at splitting up and parsing a file. as I showed you, you can actually, there's one other thing I didn't do, which is what if I want the fourth and following columns? I can say 4 and then put a hyphen after it to mean all the columns following. Boom. I typed it into sort, but whatever. So here's the fourth and all the columns after that, and then I sorted it by, I sorted it as well with numerical sort. And you can see, here we go. Here's the gigantic thing that's all nicely numerically sorted, and here's all the columns. So you have now learned how to grab stuff from the top of a file, how to take stuff from the bottom of a file, how to shuffle a file and split a file, how to write a file out or reversed in either way, how to count the number of lines in a file, how to find the unique lines in a file, how to echo single things, and how to cut columns or anything you want out of a file. These few commands, just these alone, will make up a huge portion of all of the Linux scripting that you're doing. These commands are absolutely indispensable. If you learn anything from this at all, you should learn more than one thing, because wow, how can you learn one thing? But if you learn anything, these are one of the most important things that you can learn. I strongly recommend using these in your workflow immediately as much as possible so that you get used to using them, because they are all incredibly useful. I'm of course going to put grep in there as well, because I know I had grep in a separate lesson, but grep is incredibly useful as well. Using these commands and sort, using these commands and piping them together is incredibly, incredibly useful. However, what happens if I want to cut and do other things? What if I want to I want to write out the second and third field, but only if the third field's a number and not if it's not a number? How do I do that? That's complicated. Well, you use Python, Dave. So the answer nowadays is you use Python, but before, and you use pandas or whatever. Before, like a few years ago, the answer was you use things that are going to come in the next lesson. You're going to use something called awk, and you're also going to learn sed, which is something that you'll probably use. Sed is one of those things that everyone knows of, and everyone has probably used once or twice, like we've all copied a sed command, but the next lesson as well is absolutely indispensable. You need that as well. However, it's going to be a lot more like programmy. So if you're an analyst, I'm going to warn you the next lesson will be like that. Thanks.